Coronal hole dissipated. Sunspots making the flares are departing as we saw in the opening sequence, and that's leaving the X-ray flux to crest and descend once again now. The story, of course, is in the solar wind, and yesterday we told you one more CME could impact, and indeed it did. Straight line jumps and the expansion of the red and black up top indicate its impact, and while it was relatively slow, it was pretty dense. The geomagnetic storm that popped up did not last long. The reverberations have settled in. And with this event in the books, let's look at the grades for the first 3 tests so far. The first one was about 2 weeks ago, and it was nearly a failure. A weak CME triggered a level 3 geomagnetic storm at KP7, and there was no explaining it without a poor field performance. The second one, about a week ago, was for the coronal hole stream combined with the small CME. It was late and weak and produced a level 1 geomagnetic storm at KP5, but the telemetry was rough and we gave it a pass. Only slightly worse this time. The CMEs may have been slow, but there was a good bit of density. Perhaps it didn't deserve the minus next to the B, but at this low solar wind speed, we have seen Earth's magnetic field handle these without storm activity many times in the past. Let's come to the central U.S. where the top weather alert for tonight comes in. The low will distend its convergence line down through Texas and drive powerful storms, including major tornado risks tonight, eyes open in the center of the country. Let's head over to the articles, and we're starting with the receipt of humor at NASA's expense. They are saying that their black hole simulations from 2018 are going to help them know what to look for in the future, and in addition to the major problems existing in black hole science, in this model, they don't bother modeling the single most critical and energetic point of the system, the center. That black spot in there is just empty. They told the model space doesn't even exist there, because if they didn't do that, their model flies off the rails. So when they've used that 2018 simulation to help in their informing of the universe, pretty much all we can say about the newest animation is, sure is pretty. Quick nod here as Bene Hawerda is co-author on this paper concerning dust-obscured galaxies. Our interview with Bene was a critical exploration of the dust problems in cosmology, and here they are realizing how much more of that dust there is and what it's been hiding in the cosmos. Up next, an excellent move in the right direction as they are learning more about what dynamics send the high-energy electrons from the Van Allen belts down through the atmosphere. This is critical not only because of its working of atmospheric chemistry, clouds, and the global electric circuit, but because this type of particle forcing is not in climate models. It should be, and without the particle and field forcing in total, they'll be able to blame CO2 till they're blue in the face. Nifty little bit here on solar forcing and suggesting politely it be re-examined, but doing so from a total solar irradiance perspective. Observers, that's the trash science I shredded earlier this week. And for co-author Willie Soon, who recently emailed with me back and forth for about a week, and who appears to not be taking my advice on what solar forcing is really made of, good luck with that old broken drum, sir. You will need it. Heading over to one that had me smiling all evening. The key to deep earthquakes, where there is so much friction and so much rock melt that a seismic slip doesn't really make sense. The key to its water. I'm not sure I could have hoped for a more promising indicator of what we said back in 2017, and folks, if you haven't seen our 90-minute presentation on this, it's a good one. And within it you find how it works because of how electricity works water, metal, and crystals. In Billy's lab, he makes them shift, switch places, follow the current, and even disrespect gravity as he got the subterranean water model to push back up from below, using only the currents we know are there. Last but not least, a focus on Type 1a supernova. It's never a bad choice, unless of course instead of focusing on the different mechanisms and the recurring versions at stars that don't die, you try to explain how they can use the nova events to better range the cosmos, learn about dark energy, and dark matter. Ben just shakes his head. Let's see here. Many of these blasts don't kill the star, many don't have binaries, some just go boom whenever they interact with anything at all, and some have nova events smaller than solar flares. We're approaching the end of the 12,000-year cycle when our sun is going to do this too. We greatly appreciate your support. Everything about the sun and the current disaster cycle can be found at the disaster playlist we have.